Hello everyone, welcome to another video. This is part 2 of how to explain an end-to-end CICD DevOps pipeline workflow in an interview. So I have already done one video on this, but recently we have made a lot of changes to our pipeline stages and steps within the stages. So I wanted to update you guys on that so that you can also include these changes in your answer whenever you are appearing for any interview, and this is the question that the interviewer has asked. So how to make it better basically. So as you can see on my screen right now, this is the updated pipeline that I was talking about. So it has all the things from part one, but it has some additional stages and additional steps within the stages. So as you can see, it starts with setup, validate, build, package, scan, promote, deploy batch one, and post service test. And within each stage, you have some steps. So I'm going to talk about these in much more detail. Okay, so but I highly recommend that you watch my part one and then come to this video so that you are able to understand each and everything on how to answer this question in an interview. So let's just try to understand these changes that I have made in my pipeline. So, so this part I have already explained in part one, that you have to start with explaining your company's business, the programming language or the frameworks that you are using. Okay, so all that I've already explained. Okay, so I'll start from here. Tool stack and methodology used, because I've made slight changes to the documentation here. So so if someone is asking you about the tool stack or the different methodologies that you are using to deploy your CI/CD pipeline, so you can just tell him or her that we use a GitLab CI/CD to build, validate, scan, and promote Java Spring Boot applications. Here I'm using Java Spring Boot because that's what I support currently where I'm working. But you can use any other uh, application framework as well, which you have some experience with, or you have currently supported, or you have some knowledge about that framework. So you can have any framework here, but I'm just trying to include what I know of. Okay, so we promote Java Spring Boot applications using a shift left DevSecOps approach. Okay, shift left DevSecOps means that we are trying to check the security, the quality, all the policies early in the pipeline instead of waiting until after deployment. And our container images are built with Maven and Docker. We store our images in Amazon ECR, Elastic Container Registry, and then we deploy it to AWS EKS clusters using a GitOps model with Argo CD without direct cluster access from the pipeline. So we're using Argo CD as a deployment tool which deploys to EKS clusters using the GitOps standard model. Okay, which means that you will have an repository which will be monitored by your Argo CD instance, and whenever any changes are made to that, it's going to detect it and it will try to sync the current version of the application to the version that is defined in the repo. Okay, so that's called the GitOps approach on a very high level. Then security policy checks and control promotions ensure only scanned and approved artifacts reach the cluster. So this is also we are taking care of in this pipeline. Okay, so now let's talk about the different stages and the steps within each of these stages. Okay, so this is the main part that you have to explain in the interview. And once again, I highly recommend that you watch part one of this because only then you will be able to understand each and everything. I'm not repeating a few things that I already explained in part one. Okay, so please watch part one. I'm going to put the URL of that video in the description of this video, so you can check from there as well, and then come to this video so that you're able to understand each and everything, how to explain or how to answer this type of question in an interview. All right, so stage one is setup. As you can see, setup. So this setup stage has two steps basically. First is ECR repo check. This step is going to check whether the required ECR repository exists or not. If it's missing, it's going to create so that the later image build and push steps do not fail. Okay, so maybe like it is the first time we are deploying this application. It's a whole new application for which we haven't created any ECR repository. So this step here in this stage is going to ensure that the ECR repo exists. If not, it's going to create it as well. Okay, so this will be our logic that we'll be including in this step. Then the second is EKS check. So this is going to validate that our target EKS cluster is reachable and correctly configured. So it's going to verify AWS credentials. Here I've written AWS credentials because I was using credentials when I was setting this pipeline up. But in real world, it will be slightly different because credentials are never used. But anyways, you can still just specify that all the security related, I'm sorry, all the access related part, because this GitLab pipeline has to authenticate to AWS as well. So that part, it's going to verify whether the pipeline is able to connect to our EKS cluster or not, and all the basic cluster connectivity and kube config access is available or not. Then second stage is validate. In validate, we have first we have a Docker file lint check. This is going to scan our Docker file for any bad practices like using the latest tags, or if you are running it as root, or if you have any inefficient layer. So basically, we will try to optimize our Docker file to have the optimal Docker image here. So all the good practices that are there, we need to verify, and we need to just try to get rid of all the bad things in our Docker file using this Docker file lint checker step. The goal is to catch security and performance issues before the image is built. Then we have Kubernetes policy check. This is going to validate all the Kubernetes manifests in YAML against the cluster level security and governance policies. So we are using a Kyverno policy enforcement engine here, which has a lot of different policies through which this step is going to go through, and it's going to validate whether all the manifests are correctly configured and they all comply to all the security and governance policies that we have defined in our Kyverno policy enforcement engine, and it's going to either fail or it's going to pass. So it's going to ensure only compliant workloads are allowed to move further in the pipeline. Then we have additional step, which is to check that all the deprecated APIs in our Kubernetes YAML manifests. Okay, because whenever we are upgrading the cluster, okay, from one version to the other, so we need to verify whether any APIs are deprecated or not. Okay, so this is going to check that. So it's going to check all the Kubernetes YAML files for APIs that are deprecated or removed in the newer Kubernetes versions. Okay, so yeah, then it's going to help prevent future deployment failures during EKS cluster upgrades, as I mentioned. Okay, so yeah, and then we have a Kubernetes syntax check. It's going to perform syntax and schema validation of Kubernetes manifests. It's going to ensure that our YAML files are structurally correct and it won't fail at the deployment time. So once again, all the syntax that we are using for all the YAML manifest file for deployment, for stateful sets, for config maps, secrets, and other things. So it's going to check all the syntax, and it's going to either once again pass or fail. If it passes, then it's going to go to the next stage, else it's going to fail, and then we have to fix it and then try to do it again. Okay, so this is about stage number 2. Stage number 3 is build. So we are going to build with Maven. So I'm using Java Spring Boot applications, and we're using Maven as our build tool. So it's going to run this command mvl clean package, and within our repo of our applications, we have pom.xml file where we define all the dependencies that the application needs. So it's going to run mvn clean package using the pom.xml to compile and test the Spring Boot application. The output is going to be a versioned jar file that will be used to build our container image. So this is about stage number 3. Stage number 4 is build Docker file. This builds the Docker image using the compiled Spring Boot jar from the earlier step and Docker file. Okay, so basically we're going to build our Docker image here. The image is going to be tagged with a commit SHA or build number for traceability. So this is like you can use some other parameters also here, but we are using this as our tagging strategy. So we are using the commit SHA or the build number for traceability to tag all our images that will be uploaded to ECR. Then we have build Helm chart. So we are using Helm chart to deploy our application. We are not using the individual YAML manifest file. We have a Helm chart that is going to be updated. So each time a new change is done, it's going to create another Helm chart with a particular version number that will be used to deploy our application. So build Helm chart is going to package. So it's going to package your application. It's going to define how the application runs on Kubernetes. All the environment specific values like image tag, replicas, resources are going to be templated as part of this step. Build image meta, it's a new step that we have included. It's going to generate the image metadata such as digest, tags, commit ID, and build timestamp. This metadata is later used for promotion, auditing, and GitOps based deployment. So basically, we are just trying to gather all the metadata of our image that we have built in the earlier step. Okay, and then later we can use it for promotion. The meaning of this promotion is that we will be promoting our build from dev to QA and then from QA to prod. So that's called promotion. Then in stage 5, we are going to scan our image. Just one more thing I want to mention here. So this pipeline is like a continual improvement process. Okay. So from part 1, we have come a long way. We have included a lot of things, but in future we may include a few more things. Okay. For example, just before this package thing, we can also scan our code as well. Okay, so right now code scanning is being done slightly differently here. Okay, it's not part of the pipeline, but in future I think we'll have that listed here as well. So when that is done, I'm going to update you guys and I'm going to come up with another video, but I'm just saying that it's a continual improvement process. We have a lot of steps that you won't see anywhere else, but I think we are still, we can still make some more improvements to this pipeline workflow. So as I mentioned, we can include uh, the code level scanning as well. So for example, we can include a tool like SonarQube to scan the code as well. Okay, but yeah, right now we don't have it because we are doing it differently. So yeah, but just wanted to highlight that part as well. So in scan, we're just scanning the image here. This scan image step is going to perform a security scan on the container image to detect OS and library vulnerabilities. Uh, it's going to ensure vulnerable images never reach the Kubernetes cluster. To scan image, actually we can use different tools. We can use a tool called SNYK, SNYK. We can also use a tool called Trivi that we are using now. So we are using a Trivi tool here to scan our images. Okay, so it's going to ensure all the vulnerable images never reach the Kubernetes cluster. So this step is going to fail if there are any vulnerabilities detected by the tool. Then another step is sign Helm chart. This cryptographically signs the Helm chart to prove its integrity and source. So it's like an additional step where it's going to verify the Helm chart is genuine and it's not corrupt or it's not some untrusted Helm chart. So we are using this sign Helm chart step as well. Okay, I'll try to come up with a video where I'm going to show it to you in a demo as well. But here I just want to explain the theoretical aspect. If someone asks in the interview how you're going to explain this particular question in an interview. So sign Helm chart is, as I mentioned, it's going to cryptographically sign the Helm chart to prove its integrity and source. Only trusted charts are allowed to be deployed downstream to your EKS clusters. Then sign image. this signs the container image itself, so the cluster can verify it was built by this pipeline only. It's going to prevent tampered or untrusted images from being deployed. So one more step just to verify our image as well. Here we are here we are verifying our Helm chart. Here we are verifying our image as well. Then we have a Trivi pipeline scan. This is going to run a Trivi scan against our image, the file system, and all the configuration that we have. The pipeline fails if critical vulnerabilities exceed the defined thresholds. Then another additional step is SBOM, which stands for Software Bill of Materials. So the same Trivi tool is going to scan SBOM as well. So SBOM is like whatever different libraries and dependencies you have, all the sub layers of your main what do you call Java libraries that you have. Within those, you have some dependent libraries, you have some sub libraries. So all the layers will be thoroughly checked for security. Okay, so it's called we have this software bill of material that we're going to generate and we're going to scan through. So it's going to ensure that each and every component of your application is thoroughly scanned, and if there are any vulnerabilities, those will be detected by this tool and it will be reported to us. So it's going to provide full dependency visibility for compliance and security audits. Then stage number 6 is promote, where after all this, we are going to promote to dev EKS cluster. So which means that now our pipeline is ready to deploy our application to the dev cluster. Okay, so promote to dev EKS cluster. This is going to logically promote the image and the Helm chart to the dev environment. The artifact is not rebuilt, ensuring the same immutable image is promoted. So whatever we have already scanned and verified, only that image and Helm chart is going to be deployed in this step. Then we're going to tag the build. This applies to environment specific tags such as dev or any other release candidate related tags that you are using. So tags are going to make it easy to track exactly what version is running in each environment. Okay, I forgot to switch on my webcam. So anyways, doesn't matter. So let's go back. Yeah, so then we have stage number 7. It's called deploy. It's going to generate the deploy config. So after all the 6 steps, we're going to create the GitOps configuration with the new image and Helm values. The change is committed to the Git repository, which will be monitored by our Argo CD, as I mentioned. So as soon as there's any change in this repository, it's going to be detected by Argo CD instance, and it will try to sync those changes to the current deployment of the application, and it's going to check what version of the application is currently deployed. And it's going to compare it what changes have been made in the repo, and then it's going to match it. It's going to sync it. So after we have this configuration ready, it's going to deploy. It's going to deploy those changes. So once the git change is pushed, Argo CD detects it and syncs the desired state to the cluster. No direct kubectl apply is performed from the pipeline, so it's going to just sync it basically. Okay, so that's the beauty of this tool, and that's why we follow the GitOps approach here. Then deploy batch 1. So it's going to deploy our application by Argo CD in the dev namespace in controlled batches. Okay, this namespace can be different as well, but here I've just mentioned that this application with this name. So Argo CD application name will be this. Okay, your application name -dev, which is just to specify that this application has been deployed to the dev cluster in Argo CD. So it's going to deploy the application to the dev namespace in controlled batches. Batch-based deployment reduces risk of limiting the blast radius during rollout. Then after the deployment, we are going to perform some post-service tests as well. These are basically smoke and functional tests. So it's going to run automated smoke and functional test using a Python script against live endpoints. So whatever application you're deploying, it's going to perform some functional test to verify that the application is working fine. It is functional, and it can be rolled out to users as well. So it's going to confirm the application is reachable and core functionality works as expected. Okay, so these are the 9 steps that we have now in our pipeline. But as I mentioned, these are subject to change as we move ahead and make more improvements to our pipeline stages and steps, we are going to make a lot of changes to it. But this is what we have currently. So I wanted to just, I mean, come up with this type of video so that you are also updated about all the changes. This folder structure I have already explained in part one, so I'm not going to repeat that. Okay, so once again, you can watch part one to understand other things that I haven't explained in this video. So yeah. Yeah, apart from this, another thing is the deployment and approval approach. So here, if you see the steps that I just discussed, we are following a progressive promotion model using the same pipeline and the same Helm chart version across environments. It basically means that whatever you have developed in the dev environment, only that same version can be promoted to QA, and it will be tested there, and then the same version is to be deployed to prod. So once we have promoted any version to QA, that version of application cannot change at all, because we have already done all the scanning and all the signing and everything. So that version has has to remain exactly the same, so that we know that we have already tested that. And if any changes are made, then we have to create another Helm chart version and another image version, and then again we have to go through the entire cycle. So this is going to ensure all the security and compliance of our deployed application. So a new Helm chart version is first deployed to the dev cluster, then promoted to QA, and then it is finally promoted to production, ensuring the exact same artifact is used everywhere. Then before promoting from QA to production, we can also enforce a manual approval step in the pipeline. So this is what we have enforced. Okay, so this is not visible right now, but when we are deploying our application from QA to production, in that case we have a manual approval step also. So just before the deployment, we verify that everything is fine. Only then the same QA version is deployed to production with a manual approval. So we are following the concept of continuous delivery and not continuous deployment. In continuous deployment, there's no manual approval step. Okay, your application is automatically deployed to production, but in our case we are using continuous delivery step, which means that our pipeline is going to be approved manually before it is deployed to production. So this approval acts as a controlled gate wherein authorized user reviews test results, validations, and release readiness before allowing the production deployment to proceed. Technically, this is achieved by marking the production promotion step as manual in the same GitLab pipeline, as I just mentioned. Once approved, the pipeline continues with the existing deployment steps, updating GitOps configuration and allowing Argo CD to deploy the already approved Helm chart version to the production cluster. This is going to keep the process consistent, auditable, and safe without introducing a separate pipeline. Okay, so that's what we are following here. All right, so about all these questions I've already spoken about in part one. So once again, I'm not going to repeat that. So in this video, I just spoke about the changes that we have recently made to the pipeline, and this is the pipeline that I was talking about. And as I mentioned, I'm going to come up with a hands-on video on that on this as well, so that you can also replicate everything in your environment and understand these different stages and these different stages and the steps within these stages. Alright guys, I hope you liked the video. If you did, I request you please hit the like button. Please share this with others who are preparing for DevOps and SRE interviews. And please do subscribe to my channel so that it keeps me motivated to create more and more useful content for you guys. Alright guys, that's all for this one, and I'm going to see you in the next one. Bye for now.